Dr. Afriyie. My name is Annabelle, and I'm a rising 10th grader at Plisville High School. As part of the program Branch Out, I would like to thank our guest speaker, Dr. Afriyie, for joining us today. Before we start today's career panel, I would like to briefly introduce Branch Out. Branch Out is a nonprofit organization with Veritas education leaders that was founded in 2015. It has grown from 20 student volunteers to over 900 student volunteers, with over 30,000 service hours attained. We started out as a pure STEM mentoring program working at community centers, family shelters, and community summer credit recovery programs, and counties, and have expanded into a community outreach program to promote cross-cultural understanding by featuring community career panels. As an award-winning community engagement program, we have received endorsement from the likes of Senator Tim Kaine and former Congresswoman Barbara Comstock. As part of Branch Out's goals to promote civic engagement, community, and STEM education, I am so excited to be a host for this career workshop. Just for clarification, Dr. Afriyie, this interview will be recorded and posted on the Branch Out YouTube channel. Before we get started, Dr. Afriyie, would you like to briefly introduce yourself?
Yes. First of all, I think this is a very fantastic program, and it's amazing that you guys have so many recruiters. You said over 900. You guys are doing a fantastic job. So my name is Prince Afriyie. I'm an associate professor here at the UVA School of Data Science, and I'm also the director of the master's program in data science. And I've actually been in this current post maybe this month. I just started this month. Before this, I was at UVA's Department of Statistics, and I was the coordinator. I was the director of they have a program called the +1 program where students can get a master's degree by staying an additional year. But yeah, I'm originally from Ghana, I should say. I moved to this United States here to pursue my education, my dreams of being a teacher. And so I'm very happy that I'm able to make it happen. But it's been through a lot of crooked roads to get here. But it's definitely a place where you can make things happen for sure.
Thank you so much. Let's begin. I'd like to start with your personal experience. You've been involved in statistics and mathematics for a long time, starting in undergrad. What initially led you to be drawn to this field, and what led you to focus on data science and become a professor in the field?
That's a great question. That's kind of like a long, windy answer, but so it all began in like a middle school. I was probably in like the 10th grade, or maybe before that, or ninth grade, and I was not very good at math, or at least that's what I thought. I wasn't good at math. And so I have a teacher who I quoted in most of my interviews that I've conducted over the years. We called him Mr. Science. So he was a math teacher, and he came to the class. And at that time, he was really trying to push us to learn mathematics. And so we were talking about system of equations, and he wrote a question down, and he's like, whoever can do this problem, you get 1,000 cedis. Cedis is a currency in Ghana. And if you convert it now, it's probably like 25 cents or maybe 30 cents. I don't know. And at that time, as an African student, I didn't have the money. So I'm like, I really want this money. So that was the motivator. But then I tried it. I didn't get the question right. I didn't get the money. But then that started steering me, and that made me think that, hey, I'm actually really good at math. And so I will, study a lot. Mostly I'll do a lot of math on my free time. So it was like my video game. And so after that, I went to high school in Ghana, and in high school, you declare a major before you go to high school. So I was a science major, and I get to do a lot of math there, chemistry, physics, biology. And so my natural trend from there is I started teaching my classmates, and I got very, very good feedback from from my classmates. And so what I did after that is I went to college, and I declared a math major. I did not eventually finish college in Ghana. That's when I moved to the United States, and I pursued a degree in mathematics at Northern Kentucky University. And then after that, I was like, I really want to take this all the way to the end. So I did a master's in mathematics as well at Ball State University, somewhere in Indiana. I've been all over the place, by the way. And then whilst I was taking my getting my math master's, I took a statistics course, which is actually very theoretical. And they were like, I could see all the applications of statistics, although it was a very theoretical class. And so I was like, all right, maybe I should think about this area. So I started looking at more into statistics. I think at that time, there were not data science programs. I mean, maybe there was, but very few. And so I decided to get a PhD in statistics at Temple University. And so I call myself a statistician. The field of data science um, is like a statistics. So if I have to define a field of data science, it's an interdisciplinary field, and it's a marriage between statistics and computer science. So there's a lot of code in there. Less on the theoretical side, but there's a very good application area. And so they are very intertwined. And so UVA actually have the first school of data science in the country. And so when I think the school started when I started at UVA as a statistics faculty, and I've been thinking about it. I'm like, how can I get more students interested? And data science actually attract a lot of students, and so that's where I finally end up here as a data scientist.
Thank you for sharing your personal experience. It was very insightful and inspiring. Some people use the phrases statistics and data science interchangeably. Is this
Yes,
accurate? And if not, could you explain the differences between statistics and data science?
that's a great question. I think that statistics is a traditional name for data analysis. Basically, you're trying to find insights into data based on scientific findings, right? The field of data science is actually a much newer field, although if you look back at the history, it's very interrelated with statistics. But for most schools to offer these kind of programs is actually pretty new. And I think that the key difference between stat and data science is, I mean, we solve the same kind of problems, but the key difference is data scientists rely heavily on computation. So that's why I was saying earlier that the marriage between statistics and computer science give birth to data science. Um, the field of statistics, if you get a PhD in, say, statistics, is more theoretical. So it's very, very math heavy. So it relies really heavily on mathematics. And there's less computation if you get a PhD in statistics. But data science is all about, looking at the problem, coming up with ways to find insights into them through machine learning, data mining, all those kind of techniques out there, but relies heavily on coding. So you have to know how to code a lot as a data scientist compared to, say, being a statistician. Although you do have to learn some coding as a statistician, but it's more so in data science.
Thank you for explaining the difference. There are opportunities in data science in both academia and other areas, such as working for private companies. What
Yes.
do you think students should evaluate when deciding which sector they would like to work in? Why did you decide to pursue a career in academia?
So that's another good question. All these are great questions. So I personally decided to um, have a career in academia because I really enjoy to teach. So teaching is something that I think I could do for free, but it's nice to be paid to do it. So for me, I really being in the classroom and making impact. There's a lot of teachers that don't look like me. So people like me need to get into teaching to motivate all kind of different people with different backgrounds and all that stuff. So I really I saw myself even growing up. I think my nickname in high school was a teacher. So I saw myself being a teacher eventually, and I'm glad it worked out nicely though. But yes, so you can get jobs as a statistician or data science in academia, which is a great field, or you can get in the industry or government. I think everybody, if you're thinking about any of these fields, you have to think about what your interest is. I think that, and again, it's kind of like a crazy advice, but if you're thinking about something to do, um, think about something that you could do for free because once you're in that field, you will never get bored. You're going to be very happy in your career. So, but think about what you really need to do. I think most of our students that graduate here, even in statistics or data science, some of them end up in the tech companies. So you work up, data science, data scientists at a tech company, data analyst roles. I mean, there's so many roles you can have. One distinction that I will make though is if you are looking for a position that have the label statistician. So for example, if you work for government jobs for or pharmaceutical companies, they require a statistician to be on the team other than a data scientist. Maybe people interchange those words. Then you have to maybe think about a staff major. If you're thinking about, say, a tech company or working in other industries, I think there's a lot of demand for data scientists. And one thing that I would say is if you're for those of you all of you, I imagine are in high school, but think about uh, doing something data related, not as a major, even if you want to do some, or if you want to take a few courses in college, because we have so much data in today's world, and regardless of the area that you go to, you'll be confronted with data. So having some expertise about data analysis or data science courses or coding is a very useful thing to have. And I'm not saying all of you should major in data science or statistics, but think about taking, say, a few courses there just so you can actually do the basic stuff for your jobs. But in terms of what you should decide to do, really think about something that you really enjoy because you're thinking about a career, something that you're going to be doing for the next 30 years. So you have to really think about something that you enjoy to do.
Those are definitely some important factors to consider, and I find it really great how since high school you were teaching your peers, and that helped you get an idea of do I want to do academia when I grow up? And I find it really inspiring.
Yes,
Um,
yes. And I'm sure everybody have a side of them that they actually come out either middle school or high school that they really want to think about going into. So something like that, whatever you can draw from is going to be key there.
Now, to touch a bit on the specifics of your work, I saw that you've been working on ways to better process high throughput genetic data and also have worked on risk analysis in healthcare. Would you mind explaining how data science has enabled or will enable new discoveries in the field?
Yeah. So what I do, um, like I said, my PhD is in statistics. So when I was thinking about my PhD dissertation, the topic that came to mind was something called multiple hypothesis testing. It might not be something that you've heard before, but basically, I try to come up with a method that will help you discover something when you're doing a lot of hypotheses at the same time. So I'll give you an example. What part of the data that I work on is called microarray data. So I worked with a place that does cancer research in Philadelphia. And basically they give me this data set that has the expression levels of genes in the human body. So when I say expression level, so we have about 20,000 genes in the human body. I think the numbers keep changing, but roughly about 20,000. And basically, every gene in the body can be expressed to like a number, right? And so what I did look at is for among all these about 20, whatever, how many, 20,000, 10,000, however many they are, I'm looking at the expression levels of group of people that have cancer, a particular cancer, uh, and people that don't have that particular cancer. And I'm trying to find out between these two groups of people, on average, what gene is differentially expressed between people with cancer and people without cancer on average, right? And so when you're doing that for each gene, that's called a hypothesis test, for those of you who know the term. And so by this time, I have about 10,000 of them. And so the question is, how do you prevent false positive or type 1 error? And so how do you come up with a method to do that? And so that's what I work on. An example of that, I'm not saying that that's what they used there was, I think that it's known that the BRCA1 gene causes breast cancer in females. And so the question is, somebody like Angelina Jolie, I think in 2012 or 2011, they were able to get a surgery to remove that gene because they can pay for it, right? But that gene was a discovery from something like this, where it was given that for people with cancer and people without cancer, on average, that BRCA1 gene can cause cancer. And so again, it's going to be very expensive to do it, but somebody like Angelina Jolie got that done. So that's very similar to what I did there. Um, in terms of the risk analysis that you're talking about, so I currently collaborate with UVA has a big hospital here, and they have the School of Medicine, so the cardiology department here. They look at factors that causes, health issues. And so what I help them to do is they have all these data, vast data, and I help them come up with what are some of these factors that we need to look at for people that have heart issues. And so that is something that I do it's called survival analysis.
I find it really fascinating how data science can be used to help save lives in healthcare, which is something I've really never thought about. Um,
Yes, for sure.
I also saw that you preserve I also saw that you serve on the Statistics Review Committee for Preventing Chronic Diseases, where you help advance understanding and dissemination of statistical methods and testing in the public health field. Could you explain how these statistical methods and testing have changed the public health field? Have professionals in the field been receptive to these new statistical methods?
Yeah. So what I do there is actually an appointment that I just started this year. So there's a journal at the CDC called Preventing Chronic Diseases. And this is where, people in the healthcare or people in the biostatistics area or anybody that comes out with suppose that I'm going to use this example. Suppose that I come up with a way to help prevent malaria. And I talk about malaria because it's an issue that we have in Africa. And they write a paper about uh, what their method is and how they got to make that decision that this medicine is going to help with malaria. Well, they have to write a paper. And what I do on this statistics review committee is I make sure that whatever the methods that they're using in their paper, because there's a lot of statistics and data science in that, for you to be able to make that leap and say that this medicine is efficacious, you need to do some statistical analysis. So I make sure, so if I'm reviewing the paper so that it can be published to the rest of the world, I make sure that all the statistics that they used in there is sound, has a foundational basis. I would really want to make sure that we publish something that has more scientific back into it. And so that is my role as part of that committee. And I get to review papers, we get to meet and talk about, all the papers and stuff like that. So I just started, but I've already read a few papers and it's been very rewarding.
Thank you. Um, do you have any advice on high schoolers who are interested in data science? For example, I'm sure research is something interested students would want to know more about. And would you have any recommendations for how they could find internships or other opportunities in the field while they're still in high school?
Yeah, so for students in high school that are interested in data science, I think that, you know, I think statistics courses are readily available in high school. So take a few statistics courses. If you have access to taking courses in programming, uh, make sure you do that. I don't know how programming courses are available in high school. Maybe they are. Make sure you take some few coding courses. There are also resources online, like you can take a class through, I think it's called Coursera, where they teach you how to code in R or how to code in Python, how to code in C++ or Java, whatever the coding language is. I think that is really, really setting you up for a good success when you start the program in college. Um, so once you take those classes and you can you get really into it and you get really excited about, maybe that might be an area that you can consider once you get into college. Um, there are other resources out there that will help you take all these courses online if you have an interest, even if you're not going to take it for credit. Just reading about the area, reading about what kind of machine learning tools are there and stuff like that. I think if you're really interested, you can do a lot of research on your own to see that, hey, this is something that I really, really want to do. So that's somewhere to start. Um, as far as internship, there's a lot of internship positions or availabilities for data science. And all you have to do is just search data science opportunities or internships. Um, some places, depending on what kind of classes or what kind of background you have. So if you're taking all these online courses and you're getting certifications or whatever, if you have the time to do it, that will really, really help you. Or if you can state that you are very familiar with R or Python. Um, another important piece of software is actually called SQL. So SQL. So learning all of that will definitely can get you an internship somewhere. I think that for most internship positions, once you interview for them, at least at the college level, um, there's some stages that you have to go through. Some companies will actually ask you to do, so if you say that you can code in R or code in Python or SQL, they'll ask you to do some quick coding, whilst you're interviewing. And so being conversant with stuff like that could be helpful. And some companies don't actually ask you to do that. You just have to show that apply. And one thing that I would say is you'll be surprised what you can do in life. You just have to apply yourself. So if you see something that you're really keen about, even if you don't want to apply, you want to reach out to whatever the company is just to ask them if you qualify, whoever is in charge. Just by doing that, will get you places, or by just applying and see what happens. And there's in statistics, there's something called the law of large numbers. Um, just like when you guys are about to go to college and you're filling college applications, some of you fill as many as 20 applications. I don't know the number, but if you apply yourself in so many places, at least one of them will pan out for you. So, but yeah, that's just my quick advice on that.
Thank you for your advice.
Yeah.
To end on a high note, what is the best part of your job in your opinion?
The best part of my job is just teaching students a new skill. Um, I'm very enthusiastic in the classroom. So some of my classrooms, I have about 150 students, and I don't think there's ever a dull moment. I bring a very good energy, and I get very good energy from the students' feedback. Um, I just love it. I go to classroom if I'm sad for the day in the morning, and I go to the classroom. By the time I come back, I'm very happy. I feel like I just took in a lot of energy. So I want to, even if I become a big administrator one day, that's my dream. I'll still always make sure that I'm teaching the class wherever I am.
I bet your students feel very inspired by you because of how enthusiastic you are during class. And I bet they understand a lot more than like teachers who aren't as enthusiastic.
Yeah,
Um,
well, one thing that I would say is, a lot of stuff with data science, statistics, and computer science, a lot of students think that they are not very good at it, or maybe they had a bad experience with a previous teacher, or maybe whatever it is. But some of these concepts are very basic that, I think about ways to explain it in such a way that I'm not going to be the teacher that leave that taste in the student's mouth saying that I don't like the area, right? So that's something that I think about all the time.
um, Thank you so much for your time and insight, Dr. Afriyie. This was
Yes.
an incredible opportunity to learn about the field of data science. Unfortunately, that is all the time we have for today. But before we close out this meeting, do you have any last closing remarks or words of advice?
Yes. So again, thank you for having me. I really appreciate the opportunity. I've actually been trying to seek such opportunities to talk to younger students, high school, middle school, wherever. Um, but one thing that I would say that I've learned in life is um, hard work is rewarding. Um, being very, you know, pessimistic or not pessimistic, but being determined to achieve a goal. If you really want to achieve anything in life, just write it down. I would say write it down. Think about your biggest goals in life. Write it down, and if you have a chance, look at it every day. And it's amazing how your brain can work to make that happen in your life. But thank you for having me.
Thank you.
Everyone, my name is Daniel, and I'm a rising senior at Thomas Jefferson High School for Science and Technology, and I'm joined today by my partner Annabelle, a rising sophomore at Poolsville High School, as part of the program Branch Out. I would like to thank our guest speaker, Dr. Yousuf, for joining us today. But before we get started with today's interview, I would like to briefly introduce Branch Out. Branch Out is a nonprofit program with Veritas Education that was founded in 2015. It has grown from just 20 student volunteers to over 900, clocking in over 30,000 service hours. We started out as a peer STEM mentoring program, working at community centers, family shelters, and county summer credit recovery programs, and have expanded into a community outreach program to promote cross-cultural understanding by featuring community heroes, creating research articles, and organizing career panels. As an award-winning community program, we have received endorsement from the likes of Senator Tim Kaine and former Congresswoman Barbara Comstock. As part of Branch Out's goals to promote civic engagement, community, and STEM education, I am so excited to be a co-host for this career workshop. Just for clarification, Dr. Yousuf, we're recording the interview right now, and this will be posted to our YouTube channel.
Thank you.
Before we get started, Dr. Yousuf, would you like to briefly introduce yourself?
Yeah, my name, of course, is Ali. I am currently the graduate program director at the Shady Grove campus of UMBC, the University of Maryland, Baltimore County. I am in the field of education for last more than 30 years now. I came to USA many times, but my last entry was like 15 years back. And I came from Mexico. I was a professor there for 8 years of AI and engineering design. And I still am in between these two fields of AI and engineering design. So when I came to the University of Maryland, Baltimore. That's where I started. Then I moved to Johns Hopkins University for 10 years. I worked there. And then very recently, I moved to University of Maryland, Baltimore County. And my work has been in areas related to data mining, data analysis, machine learning, and AI applied to healthcare. For at least 10 years, more than 10 years, actually, I've been working in this area of healthcare. So that's what I do now, and that's what I enjoy.
Thank you so much. Let's begin. The first question I have for you is, I saw you completed your doctorate in physics and did consulting work for healthcare companies. How did you become interested in the field of data science? What journey did you take not only to get into the field, but also hold the role as a professor?
Sure. And that's something which lots of people ask, because a PhD in physics is not what healthcare is. And the two fields appear very different from each other. But I try to tell students, especially the younger ones like you, that what you learn in school and college at university, take it as an exercise to solve problems. Don't try to memorize those things. The whole idea of education is not to memorize all those things, but to learn to solve problems. And as a PhD in physics, I learned to solve a very large number of problems, very complicated mathematical problems. And I took them not as physics problem, but as problems. Somebody gave me a problem which I had to solve. So when I left physics, when I finished my PhD, I actually spent 5 years in business, a family business. And I took again the whole business as a physics problem or a problem. And I thought of ways to improve it, to make more money, sell more products, expand the business to other cities, to other areas. And then I moved into engineering design. I took a faculty position in engineering design. And once again, I took the whole thing as a problem-solving exercise. And of course, I had to learn. So whenever you make a switch from something to something, you have to spend some time learning those things. But if your basics are good, which means if you are good in maths and stats and programming, you can survive in practically every field. Nowadays, everything is in between these three areas, even healthcare. So the engineering side of healthcare also is very heavily dominated by machines, which require very good understanding of maths and statistics, because they are very complicated machines. And when you start applying artificial intelligence to the data coming from there, again, you need very strong foundation in maths and stats and programming. So I learned a lot of healthcare on job. So I did my postdoc at the University of Maryland, where I spent 2.5, 3 years, and I learned lots of things there. I took courses, short courses, full semester courses, sometimes books reading myself, all those things. But I kept developing in the area of healthcare slowly, and worked in the area of cancer for about 10 years. Then I left cancer. I have now moved into Alzheimer's disease. But once again, I'm starting from very basics, trying to understand very basic things. And I tell students, and to my students and my sons also, who are also very young, that focus on your skills in solving problems rather than memorizing anything. And if you have those skills, you can apply them anyway. So that's how I came to healthcare.
Thank you for sharing your personal experience. It was very insightful.
Okay, next, we'd like to talk a little bit about field of data science. So, some of my friends, and I know a lot of people generally, they tend to use the term statistics and the term data science sort of interchangeably. So is this accurate? And if not, is there sort of a difference between these two fields of statistics and data science?
Frankly speaking, what used to be called statistics is now part of data science. So yeah, there is a sensitive, this is a sensitive topic, because people who have spent their whole lives in statistics sometimes feel that they're not getting the attention. But frankly speaking, they are still at the heart of all of this revolution, because to do something serious, you need to have a very solid background in stats. And that's what I tell to everyone. So data science right now is, so if you start from AI or artificial intelligence, I would say this way: the AI is the biggest blob that you have, artificial intelligence. Within that is machine learning. And machine learning is where you use statistical techniques to do lots of things. And within that subgroup is deep learning and generative AI, which is now becoming common with OpenAI and BART type of systems. But stats remains everywhere. And data science uses lots of these techniques to solve problems for the business. And yes, it is primarily statistics with ideas taken from AI also, but you are right.
And so, quick follow-up, in the future, do you think that sort of all statistical operations are going to be done using AI or machine learning techniques, or do you still think sort of, I guess, old school statistics with old statistics software will still be relevant?
Lots of things will become automatic. In fact, Excel can do lots of things for you now, which you in the past you had to do by hand. So when I started using something the equivalent of Excel 30 years back, we had to calculate standard deviation by subtracting mean from every number and doing it manually. Now there are built-in functions. And slowly, these things are becoming so powerful that you can actually write the function that you need in Excel. You can ask BART to say, this is my data, which function do I need to calculate standard deviation or correlation or all those things, and you can cut and paste that into Excel. And very soon it will be embedded within Excel. So you will have the facility within Excel to ask questions in simple language, and it will convert into formulas. So yes, a big chunk of this will become more automatic, but that doesn't mean that the value of stats or maths will go down. You will have to learn even more maths and more stats, and you will have to have a deeper understanding of those things to become very effective in industry or academia. So this is like calculators have replaced lots of work which we used to do by hand or by brain. But that doesn't mean mathematics has disappeared. It is still there. It's only that we have gone much deeper in maths now than we were 100 years back. So be ready for this, that you will still need those things, but you will need a much deeper understanding of things.
All right, thank you so much for your answer.
There are opportunities in data science, both academia and other areas, such as working for private companies. What do you think students should evaluate when deciding which sector they would like to work in?
To some extent, it depends on the personal choice of students also. When you grow and you go to PhD program, at that point, most of the students begin to see their career as something, either as academia or in industry. I can tell you, I have worked in industry full-time for many years as a data scientist, and I can tell you that for most of the big companies, it doesn't really matter where you are, because the big research groups within companies are also like university research groups, which means you only talk to people who are in your area, you do maths and stats and programming and very intellectual discussions, you publish papers and all those things. Yes, business has one big focus. They want to make money. So ultimately, that objective is there. Compared to a university, that objective is there, that the boss would like to see, what did you do in the last 2 years? I was paying you that much. What is the outcome? But from my point of view, that's a very interesting twist, because that keeps you focused. You don't start exploring things which don't take you anywhere. You remain focused. You still do the same kind of work that I was doing at Hopkins. I was doing at the company also, but it was more focused. And it was more rewarding because in healthcare, when you end up doing something good, you feel very happy because you solved a big problem. You predicted something which was not possible in the past. Now you know that this person is going to have the disease in 2 years from now, which was not possible. So based on data science and AI techniques, we predicted certain diseases ahead of time. So that was a very rewarding outcome, which you get there. But practically, keep in mind that data science is becoming so common everywhere that getting jobs in academia itself may not be possible for everyone. That will become difficult, and that has always been the case. When I did my PhD in physics, it was the same problem, that there were only 2 openings, faculty openings, and 20 PhD students waiting. So people had to find ways, and I now suggest to my students that start thinking on those lines early. So rather than feeling the shock suddenly that now you don't have a job, no, prepare your mind that that is also an option. And if you are in USA, the industry is so advanced that you can get a job where you hardly feel the difference between a company and a university. They both look same in many ways.
Those are definitely some very important factors to consider.
Hi, Dr. Yousuf. Now I'd like to talk a bit more about your specialty, which is sort of in healthcare. So I know we kind of touched on this before when you mentioned like being able to predict diseases, but could you explain a bit more how AI has changed healthcare? Like, for example, what approaches are now possible that were impossible to think about before AI and data science were integrated into the field?
Sure. So let me pick some examples from things which I have done. So one problem which I was working with the company where I was working, they essentially get all their data from health insurance companies. And lots of different companies in USA, they give their data to this company to analyze and help them predict future outcomes. So they already have data from 1 million people, more than 1 million actually, 5 million people, 50 million people who have gone through different medicine, different types of surgeries in their lives. And ultimately they develop, let's say, a problem with their knee, and they had to go to a major knee surgery. And the question was, can we predict based on the medicine they were taking? So they were taking painkillers, for example. So if you are taking painkillers and somebody goes to a patient first, let's say, or a hospital, and tell them that I have a problem with my knee and I need some medicine, the person will get that medicine. The question is, how many times, if you take this means you have a serious problem coming up. And that comes from data. So we had billions and billions of data points available to see through AI and find out which are the people who are most probably going to have a major surgery in the future. What's the advantage? The advantage, there are many. First, if you can tell a person today that you are in threat, you can have this major problem coming up in 2 years. Be careful, stop doing, let's say, excessive exercises. And if you're not a very active person, start walking outside every day, do something. You will save that patient from the trouble of going through surgery, because surgery always has consequences. So it can take months to recover from that surgery. You can also lose your job depending upon the job you are doing. From the point of view of insurance companies, they save money because they will not be paying you now surgery cost. They caught the problem much earlier and they solved the problem much ahead of time. So they are also happy. And finally, the physician is happy because physician's job is to provide you better care. Because if you get better care, you will take your son also to the same place. You will recommend your father and other people that, yeah, he's a good guy. He knows what to do. So ultimately, everybody in the chain is happy. And AI helped us predict ahead of time what is there. So that's one example that I did for the company. And we could publish papers, but publishing papers at industry requires lots of permissions because for them, this is proprietary knowledge. They don't want to publish immediately. A similar project that I was working at Hopkins was even more interesting, and I left a bit earlier than it was completed. But the idea there was people who have a brain stroke patients, they go through an MRI or CT scan of their brain to find out what is going on. And the problem there is there are two different types of CT scans available. And each scan requires its own setup. So the patient goes to scan 1, get the scan 1, the physician sees it, and then he recommends the second one, which takes another 2 weeks to plan. It has a cost. It has a cost for the patient because these patients generally are weak. They have to be carried to the hospital by family, something. And the idea there was, if looking at the first image, can AI predict the second image that will come out after 2 weeks? And how do you do this thing? You do this thing by looking at historical data. So we had data of thousands of patients at the hospital who had gone through both these CT scans in the past. So we trained a deep neural network to understand the relationship between this scan and this scan. And we showed them 5,000 scans. And then we gave them a new scan, only type 1, and say, what do you think will be the type 2 scan? And the AI predicted that this will be the next one, which means the physician knew ahead of time, 2 weeks ahead of time, that this patient is going to have a serious problem because that CT scan will show me, will prove it, but I already know the problem. So ahead of time, I can stop it. I can start giving medications. I can do all sorts of things for the patient right now. Still, the patient will have to go through the second scan, but the care will start 2, 3, 4 weeks ahead of time. And in case of brain stroke patients, that's a lot of time. They don't have much time. If one more mistake and they can die. Therefore, that kind of work, although it's very, and that also required quite a lot of maths behind the scene. It was lots of maths. So those are applications of AI in healthcare, and there are many, many, many. If you look at it on internet, you will find many more, but those are two good ones.
All right, awesome. Thank you so much for providing those examples of what data science and AI can do in the field. I'd like to touch now on sort of advice for aspiring data scientists. So do you have any advice for high schoolers or other students who are interested in data science? Like I know that, a lot of high schoolers are trying to look for research or internships or other opportunities. Would you have any recommendations for how they could, seek these opportunities out?
Sure. So I have worked with high school students a lot in the past. I already have a student right now who has just finished his high school, and he and I have a paper accepted already at a conference in Florida. Students who come from high school, they have to have a few things in hand. First of all, you should have a focus. You should have something that is close to your heart. So for example, if your grandmother had some problem with cancer, let's say, and you were close to your grandmother, you will probably be more interested in exploring that area, because to do some research, you require quite a lot of motivation and commitment to that field. You will have to learn hard things. You will have to spend extra hours in the night to learn all those things. And that cannot come just because I told you to do so. That's not how you can do research. To do research, you have to have a passion for that field. So my first recommendation is find a passion for yourself. And passion generally comes from something that has happened around you. So if I'm interested in Alzheimer, it's not because of something unusual or somebody asked me, but because I saw someone who suffered, who I was very close to, and I realized something has to be done with this disease. Something, let me contribute, let me see what I can do. So that's one thing. Find your passion, what exactly you want to do. It can be chemistry, it can be maths, it can be physics, it can be astronomy, it doesn't matter, but find your passion first. Then be ready for it. And ready means for most of the things, as I said, is maths, stats, and programming. So you need to learn math, stats, and programming in addition to having, so these 4 things put together, a passion for something that you want to do, and then math, stats, and programming put together. Develop as many skills as you can through YouTube. Free courses are also available, which you can, and then find people at universities who are working in your area, and then write to them and see if they are willing to have undergraduate students or high school students, and then start working. So students do come to universities. At Hopkins, I had many more. Right now, I don't have that many students. At Hopkins, I used to have more students. And essentially, what I expect from them is a passion for what they are doing. If you have that passion in that area, you will probably stay with me for a few months, and you will be able to do something. At this point, I actually recommend very strongly to all students to do it for 2 reasons. First, universities have started looking at it now. So when they look at your resume, when you apply for admissions to undergrad programs, they look for your past experience, and it helps. When I was a student at your age, nobody cared about research up to the end of master's degree. But now high school students are expected to do something. The world has changed. It has become very difficult for students to survive because universities have started comparing, because 2 students applying with the same type of grades, now they have to decide which one to take, this one or that one. And this research also becomes a very clear signal that, yeah, this is the person to get. So I strongly recommend that if you can find a way to work with anyone, And most of the people nowadays can work through Zoom also. So you don't have to go in data science, you don't have to go anywhere. When I had students in engineering design, they had to be brought into the lab to do some design work because engineering design required a lab. But with data science, you essentially need a computer and that's it. So if you want to work in this area, I would recommend looking for professors who are in your area of interest and who have time. Not everybody has time. I also have limited time. But if they had time, you write to 4 or 5 people, somebody will say, yes, let's find something and start working.
All right. Thank you so much for your advice. It was really helpful.
You're welcome.
To end on a high note, what is the best part of your job, in your opinion?
So I enjoy being academia mostly, but my main interest always is to solve problems. Whenever I get a chance to solve problems, and especially for last 15 years in healthcare, that I find very rewarding. So when I did my PhD in physics was very mathematical in nature, and there was no immediate application of that knowledge. So that was essentially colliding particles at very high energy and seeing what comes out of it. Very noble probably, but no applications, no immediate applications at least. What I enjoy now for last 15 years is because whatever I do, essentially next week, it can be applied somewhere. So the data that we have, everything can be applied. So we work with hospitals, we work with physicians or patients, and whatever we do, whatever methods we develop can be applied immediately. And that gives a lot of pleasure, a lot of satisfaction that the work that I have done has turned out to be useful. You have to be very careful, of course, because you don't want to risk a patient's life in any way. That's why there are so many security measures in between, so many people to check your work. But the advantage is you do it today, within a month, you see the effect of it. And that's very rewarding.
All right, well, that was our last question. Thank you so much for your time and insight, Dr. Yousuf. And this was a great opportunity to learn about the field of data science. And before we close out this meeting, do you have any last closing remarks or anything else you want to say that we haven't touched on before that you believe is important?
Well, the only thing I would like to add is life is difficult. It is challenging. It's not going to be easy. Just keep in mind that people will always doubt at your knowledge. They will doubt at your intelligence. They will tell you that you can't do it. This happens all the time. Even at universities, it happens. It has happened to me. It has happened to almost everybody that I know of. Don't give up. Never give up. Keep pushing, keep pushing. Even if you fail, so what? Lots of people fail. All big scientists fail. Everybody fails. Failing is not a problem. As somebody said, failing is an option. Giving up is not an option. So you don't give up. If you fail, you try again, try again, try again, try again, and keep trying. It's a lot of hard work, but you will get something out of it if you keep working hard. And that's my recommendation.
Thank you for those pieces of advice. It was very inspiring.
Hello, Dr. Simsek. My name is Daniel, and I'm a rising senior at Thomas Jefferson High School of Science and Technology, and I'm joined by my partner, Annabelle, a rising sophomore at Poolsville. I would like to thank our guest host, Dr. Simsek, for joining us today.
Before we start tonight's career panel, I would like to briefly introduce Branch Out. Branch Out is a nonprofit program with Veritas education leaders that was founded in 2015. It has grown from 20 student volunteers to over 900 student volunteers, with over 30,000 service hours attained. We started out as a peer STEM mentoring program working at community centers, family shelters, and county summer credit recovery programs, and have expanded into a community outreach program to promote cross-cultural understanding by featuring community heroes, creating research articles, and organizing career panels. As an award-winning community engagement program, we have received endorsement from the likes of Senator Tim Kaine and former Congresswoman Barbara Comstock. As part of Branch Out's goals to promote civic engagement, community, and STEM education, I am so excited to be a co-host for this career workshop. Just for clarification, Dr. Simsek, this interview will be recorded and posted to the Branch Out YouTube channel. Before we get started, Dr. Simsek, would you like to briefly introduce yourself?
Sure. My name is, in fact, my name is Ergun Simsek, and I am originally from Turkey. I came to United States in 2001 for my graduate study. I received my PhD in electrical engineering in 2006 at Duke University. Then I worked as a postdoc for like almost 2 years at Schellenberger Doll Research Center. So like, I spent a couple of years in industry and academia, but since 2018, I am with UMBC, University of Maryland, Baltimore County. Right now at UMBC, I'm an assistant professor and I'm also the director of UMBC's graduate data science programs.
Thank you. Let's begin. The first question I have for you today is, I saw you completed your degrees in electrical engineering. How did you become interested in the field of data science, and has electrical engineering helped you in the data science field? What journey did you take not only to get into the field, but also hold the role as a professor?
Okay, that's a really good, great question. But before I give my full answer to that question, so let's go through like step by step, and let's discuss what is data science, what is it about, and then I will answer your question. So if you talk to people, but first of all, data science is a very big community, and it has people from all different backgrounds. Like originally you might think data science is just full of data scientists or like people who studied computer science, but it's not true. We have people from all different backgrounds. And if you talk to those people and if you ask what data science is, you will probably get so many different answers. So National Academy of Engineers and Sciences, they come up with their own definition, and they say data science is basically finding patterns or like pieces of data which is invisible to our human eyes, obviously, from very complex and generally speaking large data sets. Okay, and at the background there are three main thrusts. So one of them is, of course, math and statistics. The other one is computer science. And the third one is actually domain knowledge. So domain knowledge, it depends where you are applying this, the data science projects. And right now, we are using data science actually all over the place. Like if you are going, let's say you are visiting google.com and you are doing a just a simple search. Actually, there is a piece of AI, artificial intelligence back there, because when you are writing, you can see that it is giving you some recommendations about what you should search or what you might search, right? Or if you just watch Netflix, based on the movies that you watch, it gives you some recommendations, right? So like these are all different applications of data science. And in fact, today, like we are using data science in like e-commerce, manufacturing, agriculture, banking, healthcare, transportation, and even finance. So it's all over the place. And like why I jumped in data science back in 2006, actually, there are like multiple reasons, but let's start with the following question. So like data science has been very popular both in the United States and also in other countries in the, let's say, like past 10 years. So the question is like why it is super popular right now. There are multiple reasons. The first thing is, of course, the amount of data that we are generating, right? Right now we all have those smartphones, we have tablets, we have different devices, and we are taking pictures, we are uploading those pictures to Instagram, Facebook, or we are using applications like Google Maps or Waze. So constantly we are generating data, and this data is actually, the amount of data that we are creating is increasing exponentially. So that is number one. But number two, actually, it is very related to this data that we are producing, how we store data, right? So here, for example, you see this large capacitor, which basically is a like a memory, like a hard disk. And IBM was selling these hard disks in 1960s for $50,000. And back then they were only holding like 5 megabytes of data, right? But if you just go to Amazon.com right now, you can buy a 1 terabyte of like a USB stick for like $50-$60. So meaning, what I'm trying to say is storing data is just getting cheaper and cheaper. And the third one, which is like, these are bad boys. So these are like called like GPUs, graphics processing units. And we also have like TPUs. tensor processing units. So these are specifically created for machine learning applications, and they allow us to do machine training and also testing extremely fast in very short periods of time. The fourth reason, now we have tools such as like Python on TensorFlow, Keras, which allow us to do machine like data science for free, and these are extremely simple things to learn. And the last but not least, we also have some platforms like Google Colab or GitHub to develop our own machine learning algorithms or implementations codes, then also store our data sets on, like, for example, GitHub. Then as you said, like my original background is in electrical engineering, and actually we do lots of scientific computing, like scientific computing for applications in photonics and in machine learning, in photonics originally. But the true answer is, like, in 2016, I went to an EM conference, like electromagnetic conference, and that people were like not very excited. They were all talking about very incremental improvements in their research. But it is in the same very year, I also went to another conference, which was an AI conference, like artificial intelligence conference, and I saw that super excitement, that people were talking about new subjects, new research areas, and all those different breakthroughs. And I said to myself, okay, like all those years I've been doing scientific computing for applications in photonics and electromagnetics, maybe it's time to make a change in my research area. And back then, I started to first teach myself how to build machine learning platforms, then implement different solutions for different applications. But I'm very glad, because my background in electrical engineering provided me a very strong background in mathematics, vector calculus, statistics, and linear algebra. And since I was doing lots of programming, it was an easy transition for me to become like a successful researcher in the field of both data science, artificial intelligence, and machine learning. Yeah, so this is pretty much it.
Thank you.
Okay, as you discussed, you've been doing research in electrical engineering, and you said that data science has played a role in like your photonics research, for example. Could you give us an example of some of the research you've done where data science has sort of proved instrumental to achieving the results that you found?
Actually, there are so many examples I can give you. Like many years ago, we were doing this inverse electromagnetic inversion. So electromagnetic inversion is basically this. So there's a black box, and in that black box, there's some things, there are some objects, you don't know what those objects are, where they are, and then you have a bunch of antennas around that black box, and you are using electromagnetic waves to detect those unknown objects. It's similar to X-ray scanners in the airports. So before, many years ago, we were solving some integral equations to identify those objects. But in each case, we were starting with some initial guess, we were solving those integral equations for many times iteratively. At the end, we were obtaining a solution. So what happened with machine learning or with data science is that now, instead of starting from scratch every time for a given problem, so what we do is we rely on data. So we rely on we have these data sets of for a given different problem. So we learn from those data sets, then we solve whatever the problem is given to us. But the initial guess is actually it is very close to the after of course after doing this training, we can have a really good initial guess of the final answer. In photonics, people are using machine learning for many different applications. So the biggest one is actually device design. So how can we design a photonic device by using machine learning? Let me give you one example. For example, here, this black box you see on the left, it's a beam splitter, power splitter. So it has only one job. So we will provide some electromagnetic waves or pulses from the left, and depending on the polarization, this light will go from the either top waveguide or the bottom waveguide. Okay, so let's say if it's a TE, it's supposed to go from the top waveguide. If it's a TM, like transverse magnetic polarized electromagnetic wave, it's supposed to go in the lower branch. Okay. Traditionally, what we do, what we do is, we come up with some numerical solvers to design these structures so that the output will be maximized depending on the polarization. But like by using some iterative solvers. So what happened is with the machine learning or data science, people realized that the very same problem actually can be solved with multiple different approaches, and one of them is called adjoint method. So adjoint method, it has a long history, but in device design, people started to use in early 2000, and there are a bunch of groups at Stanford, at Caltech, at Berkeley, and they realized that they implemented this algorithm to come up with a very unique designs. So, for example, here I'm going to show you a design generated by Professor Vuchkovich's group at Stanford. And if you look at this shape, right, this gray thing is the power beam splitter designed by the adjoint method, and it looks extremely complex. Like traditionally, the human, when we design devices, we generally make them symmetric and some simple shapes. But this device is extremely complicated, and if you actually do the experiment, you will see that indeed, when you excite this structure with the TE wave, it will go from the top channel, and when you excite it from the TM wave, the transverse magnetic, the output will the wave will leave this platform from the bottom channel. So this is a pure machine learning designed device. So the long answer in short, so we are using machine learning algorithms to design devices, both passive and active devices. We are using machine learning algorithms to replace the solvers. Like normally we have those filtering or electromagnetic solvers. Sometimes they take a few minutes, sometimes they take a few hours or days. But now, if we have large data sets, actually we don't need to even solve or use those solvers to get the solution, because machine learning algorithms can predict the solution for us. So that is area number 2. Area number 3, in photonics, people are using machine learning a lot, which is material characterization or material design. Again, for let's say you have an objective and you don't know what material to use. So machine learning algorithms can tell us precisely what material or what should be the optimum parameters, such as permittivity, permeability of those materials to be used. There are so many different applications, but indeed, machine learning changed the way we are looking at the field of photonics. It is a totally different era right now.
Thank you so much for giving us that insight and explaining a few ways how data science has changed the field.
You're welcome.
Some people use the phrases statistics and data science interchangeably. Is this accurate? And if not, could you please explain the differences between statistics and data science?
Yeah, it is not accurate. It's not accurate. Like statistics and data science, they are very, very different from each other. So statistics, is a branch of math. And in data science, we are using statistics a lot. But I wouldn't say that, because some people say, oh, machine learning is the fancier version of statistics. This is not true. And I can give you a couple of reasons. So first of all, in statistics, you have this nice tabulated data set, and you are trying to make some inferences about populations, right? But on the other hand, in data science, it's not only about understanding what's going on, but also making predictions. Sometimes, for example, what we do. So there are nonlinear relationship between inputs and outputs. But with data science, we can actually create devices or design devices, which, even though we don't know anything about that nonlinearity, but those neural networks, those hidden layers, those neurons that we are using, they have the ability of learning those very complex behaviors. In statistics, most of the time people work with very nice, very well structured data sets. But in data science, that's not true for most of the time. And actually, if you talk to data scientists working in the field, in the industry, they will tell you that 60% of their time, or sometimes even more, they are doing this data wrangling, meaning that they take that data set or data sets. There could be multiple of them, and those data sets, they don't have to be the same format. You might have some tabulated data. You might have a image data set or sound data set, right? So bringing those data sets into the same platform, it's a very serious progress effort. And again, in data science, we are dealing with that. So in statistics, most of the methods and tools or techniques are like very standard, like ANOVA, or like the hypothesis testing. So they're all fixed. But in data science, actually, the number of tools and methods, that is the sky is the limit, by the way. Like there are multiple different methods, and also you can create your own methods. You can create your you can actually design different neural network architectures depending on your type of the problem. So that there is again like a huge difference between statistics and data science in terms of the tools and methods. And the other thing is if let's say there's a statistician, right? If you give them a data set, no matter what the data set is about, it could be healthcare, finance, so they can carry out their typical studies, and they can tell you the basic informations about that data set, like very precisely, right? But on the other hand, in data science, some sort of domain expertise is required. It's not only about just some CSV files or some data files, but you have to have some domain expertise. And this is why actually we have so many people from very different backgrounds. If you a couple of years ago, I went to visit old friend of mine. He's a director at one of those private large data science companies. And when I met people, I was extremely surprised. There were people from who studied psychology in the college. There were people who studied music in the college. And to be honest with you, I was quite surprised, because I was expecting a room full of computer scientists, but apparently that's not the case. One of the projects, again, I shouldn't say their name, but it is one of the biggest sound system producer companies of the world, and they are working with a car manufacturer, and they wanted to use the sound system available in their cars to learn the physical status of the car. Again, I'm not allowed to give so much information, but what they did is, so they brought sound engineers and musicians to take care of the sound processing part, and then they combine those people with machine learning people, and in the end, now they can learn the physical status of a car when it is actually moving from the sound waves recorded by the microphones embedded in the car. So again, this was a very nice implementation, data science project. But so we have different people. But if you talk to statisticians, they are all people who studied math and statistics at the college. So again, there's a huge difference between education and what they do in the field. So statistics is not equal to data science. We are using statistics a lot, right? For example, let's say you're going to implement a data science project, right? So how many samples do you need in your data set? Is it 10? Is it 100,000 or 1 million? So we make that decision based on statistical tests, and so that part definitely relies on statistics. But what we do in data science is very far from statistics. Just think about those neural networks, right? I don't want to say anything discouraging about statisticians, but there's a huge difference between statistics and data science.
Thank you for explaining the differences.
No problem.
The next, I'd like to talk a bit about, I guess, the jobs in the field. So there are opportunities in data science in both academia and in industry. So what do you think that students should evaluate when they decide, what sector they want to work in, and how did you decide that you wanted to work in academia versus industry or government?
Okay, that's another good, very valuable question. First of all, you need to ask yourself, like, let's say you are a student and you are interested in doing anything, but first you have to ask yourself, what do you enjoy most? Um, um, so like I did 2 internships in industry, and then I just realized that I enjoy academic life much more than industrial life. So you should do the same thing. You should test it by yourself. But let's look at 2 different perspectives. Perspective number one is the following. So how a data science project is conducted in industry, right? So in industry, so the main goal is, of course, always making products better, increasing the profit, etc., etc. So there must be some business questions or like business goals, right? And there needs to be a team which understand that business goal. So that's step number one. In step number two, in order to meet that, or in order to meet that goal, we need to have data sets, right? And of course, in all those companies, we have thousands of data. They have like, I'm sure like they have like very large data sets, but we need data mining people to go out to their servers and find out the most valuable information which might be useful in this data science project. But that data set probably will not be good enough to be used in the first step. So then data cleaning part will kick in. After data cleaning, let's say you have this data set with thousands of features. Of course, you don't need all those features. You will need to do some feature engineering to get rid of the unimportant ones, etc. Then you will build some models, and based on those models, you will get some answers, and you will then test the accuracy of those predictions, etc., etc. And in the very last step, of course, you will need some a fancy data visualization to summarize your findings. So this is how a typical data science project is conducted in industry. But in academia, it is totally different. In academia, the starting point is a research question, right? Like we would like to design like a new device by using machine learning. So what should we do? What method is the best one? So once you have this nice question, then you need either like a data set, or you need to build your own model to answer that question. Then then you will build that learning platform, you will train it, and in the end you will get some results, and you need to analyze and visualize those results, etc. So I think the main difference in academic research and industrial data science is so in academia we decide what to work on, right? We come up with those research questions, but in industry the main drive actually comes from the upper management, or like our boss or our boss's boss. And personally, I'm not very happy with that type of approach. I want to ask my own questions. I want to find my own answers. In academia we have a great freedom, so that's why I really like academic environment. But a high school student at this level, like at this very early age, I think it is quite early to ask this question. So what you should do is, to me, just go to college, right? Start studying, then do some internships. But you should definitely do some industrial internships and see which one you like more, like working with a professor on a cutting edge research project, or making money, or making your company richer. People have different objectives, different goals, and of course there are differences in terms of money you can make in industry versus academia. Of course, in industry you can make more money, but in academia there's a higher amount of stability. So yeah, it depends on the person and their goals and dreams.
All right, thank you so much for explaining the difference and giving some advice on, how students could figure out which sector they'd be most happy with.
No problem.
Do you have any advice for high schoolers who are interested in data science? For example, I'm sure research is something interested students would want to know more about. Would you have any recommendations for how they could find internships or other opportunities in the field while they're still in high school?
Yeah, at the high school level, first of all, I'm since I didn't go to high school in the United States, I'm not very familiar with the system here. But probably it might be difficult to find the industrial internship at the high school level. Yeah, but it's not true for college, right? In academia, all those professors are actually looking for high school students who can join their research teams, and we really appreciate this. We really value this. And if I were you guys, I would just send an email to a couple of professors who work in the field of your interest, and telling them that, hey, I study this. I want to join your research group. Is there any internship possibility, like summer internship possibility? And I am sure like 99% of the time you will get a positive response. But if there's a high school student interested in like data science, there are a couple of things. The first one is, so data science rely on vector calculus and statistics a lot. So you need to make sure that you have a really good understanding of vector calculus and also a little bit of statistics. And the other thing is, like, most of these projects are done today in Python. Of course, there are some other languages, but if I were you, I will start learning Python programming like today. There are so many free online courses, free ebooks. So we have this Google Colab, right? Like if you just Google it, like Google Colab, everyone who has like a Gmail account, they have a free platform to do Python programming and also machine learning. So I would definitely start learning Python programming, because if you have that talent, then you will be useful for any research projects. It doesn't matter if it's academic or industrial, it will be really great. And the third thing is, which is very important for me. So like, because people come to me and they say, hey, I'm very interested in data science. And then I ask them, like, what kind of data sets did you play with? And if they say that, oh, I haven't done anything, then I feel awkward. So I think you should really start playing with data sets. It doesn't have to be a data science project. It could be as simple as a CSV file. It could be as simple as analyzing that CSV file, like columns and rows, the mean values, maximum values. It could be as simple as this. But in the end, you will learn how to open a CSV file, how to do some basic EDA, like exploratory data analysis, then like maybe doing some like basic visualizations. So this is where you should definitely start. So if you go to a professor or someone in industry saying that, hey, I have very strong background in calculus and statistics, I know a little bit of Python programming, and by the way, I have some experience with working with different data sets, like data files, like, I don't know, CSV files, MP3 files. That will be definitely an enough ticket for you to join either an academic research group or industrial research group. So yeah, again, like I'm not very familiar with the internship system in the United States at the high school level, but I am very familiar with the academic system. So first, I would trying for finding an internship at a college, which in Montgomery County in Maryland, we have not Montgomery County, but in Maryland we have the College Park, we have UMBC, we have Johns Hopkins, we have so many, like AU. It is actually in DC, but like we have so many universities, and there are so many professors from different fields and backgrounds. They are all working in the field of data science.
Thank you for your advice.
All right, Dr. Simsek, thank you so much for providing that advice on how high schoolers can get involved, and providing many different opportunities, such as learning about Python, playing with data sets, or finding internships. So we have one more question today, and to end on a high note, we just want to ask you, what is the best part of your job in your opinion?
Oh, like my job has so many best parts. I'm really happy that I'm a professor. I'm working in academia. Like if I can give you a couple of examples, like why I love. The first one is actually like intellectual fulfillment, right? So like we are always going after like something new. Like I wouldn't be happy if I was doing the same job every day, again and again. But in academia, like when you are doing research, or of course you can also do research in industry, But going after something new is really very exciting for me, and I feel like super energetic every morning, every day, just because of this like hunger for finding the new stuff. The other thing is, like, in academia, like, we decide what to work on, right? We choose our own subjects, so that freedom is really great. And it's also true for teaching. Like, we for example, last semester I said, okay, I want to teach a new course called like photonics and machine learning, and I had this freedom, so it is really great. Other thing is, like, when you do research, when you do teaching, mentorship, you are always actually contributing to society. Like, for example, here today I'm here with you guys, right? I don't know, probably if I was like a carpenter like my father, I wouldn't be here today. So this is really what I like about being a professor. Teaching is really great. I very appreciate my students, and when I see like they are learning and they're implementing new stuff, it really makes me super happy. And also especially for like graduate students, we mentor them for like many years, and at the end, they become like professors like us, or they become like successful data scientists and engineers. That's also something very nice to see. Another great thing about academia is, like, it is like all about learning new stuff, right? So in the, like, as I told you in the beginning, my background is in electrical engineering, and my original field was electromagnetics. Then I switched a bit to photonics. Then I saw this machine learning is coming very strongly. Then I learned about machine learning. So it never ends. It never ends, and I think it is one of the reasons, one of the things like driving me every day to do more. Another very great thing about being in academia is, like, we have almost unlimited resources. So some of these resources are from like hardware perspective, like we have, for example, high performance computing facilities. We have all those labs, and some of those resources are about like libraries, or having this access to thousands of journals. That's also great. But last but not least, conferences, right? So we do research. We submit our we submit some manuscripts about our research, and then we attend so many different conferences. For example, last month I was in Europe. First, I went to Munich for the CLIO conference. CLIO is like lasers and electro-optic conference. Then for 2 days, I went to Berlin to see my college friends. From Berlin, I went to Prague, Czech Republic, for the Peers conference. So I spent like a week in Prague. Then I went to Turkey to see my brother. Then I took my kids and wife to French Riviera, Italian Riviera, and then they went back to Turkey, and I went to Paris for the Peers for the Meta conference. And Meta conference was unbelievable. All the big names of our field, from, like, for example, I talk about Vučković a couple of minutes ago. She was there. She gave us a great talk. I also made like 2 presentations, and at the very end, I stopped at Iceland for a short period of time. Then I came back. But the thing is, like, through these conferences, when you are a professor or like a researcher, you get to visit the entire world, and it is really something I really appreciate. And hopefully, like, some of you will become researchers and professors, and you will do the same. Continuous research, continuous learning, continuous travel, and other thing is, like we always get to work with young people, and the energy of those young people really give me energy as well, and then I don't stop working.
Thank you so much for your time and insight,
You're
Dr.
welcome.
Simsek.
Okay, it's my job. Thank you very much for having me.
This was an incredible opportunity to learn about the field of data science. Unfortunately, that is all the time we have for today. But before we close out this meeting, do you have any last closing remarks or words of advice?
Like, my actual advice to any high school student would be like following stuff. First of all, so you have this bright future in front of you, right? And sometimes I see those kids saying that I don't want to work, I don't want to study. It really makes me feel like it makes me feel really sad. Like, colleges are beautiful places, great places. Like you will have all those years to learn new stuff. You will have all those great professors. You will have all those great classmates. Okay, so you should use that time very, very effectively. So when I was in the college, I didn't know much about exchange programs. So if there's an exchange program in your college, please use that experience. Go to another country, especially to a country where they don't speak English, or where they have a different alphabet, like in Greece or for example, Korea. So that experience will teach you a lot. So I would strongly recommend doing an exchange program in the college. The other thing is, I was just talking to my friends, and like we were choosing the courses that we want to take together. Don't do that, right? So at the college, you have all those experts from different fields. So you should ask yourself, like, what do you want to do like 5 years from today, 10 years from today? And then you should choose the courses that you want to take based on your dreams, based on your goals. So the college years are extremely important. The other thing, of course, like you already know, but especially in the United States, GPA is important. So you need to make sure that you're working hard and you are keeping your GPA high enough, because GPA will be the key for many, many things after the college, right? So having that high GPA is crucial. Yeah, other than that, like right now, like we have so many different things going on. Just look at what happened with like ChatGPT, right? It's about to change the entire education system, entire planet. But we should use all those opportunities for our good, right? Like 30 years ago, 40 years ago, people some teachers, they were against using calculators, but think ChatGPT or something like that as your assistant, and improve your efficiency. So you should use all those resources for the good, and the rest would be just working hard and having good time. So that's it.
Thank you for your advice.
No problem. Thank you very much. Thanks so much for having me. I really hope some of you will join us. I mean, like the field of data science, to the field of machine learning. Some of you hopefully come to us like at the UMBs or of other Maryland universities. But I really wish you to great success and like motivation to study hard at the college and later.
Thank you.
Thanks so much.